Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides additional practice using StatCrunch to conduct hypothesis testing and construct confidence interval estimates for two paired population mean values. Let's get started. So to start off with, we're going to be looking at an example here that involves weather forecast data. So we've got 8 randomly selected days in September, and then for that same, for those same days in the same month, we're going to be looking at the actual high temperature and then the predicted high temperature that was actually made 5 days in advance. So we've got a paired data set here. Notice we've got the same standard questions that we're typically asked with these types of problems. The claim is that the high temperature forecasted 5 days in advance is on average different than the actual high temperature. And you want to talk about someone who got the weather wrong. Check out Bill Murray there in the corner. I mean, if you don't recognize what movie this is from, then I'm sorry. I just don't know how to say it. Your education is woefully deficient. Okay? This is from the movie Groundhog Day. If you haven't seen this movie, oh man, you gotta see this movie, okay? It's a pretty funny flick. It's also kind of thought-provoking in its own way. And so, yeah, if you haven't seen this movie, you gotta see this, okay? I truly think this is one of Bill Murray's finest performances. Anywho, let's take a look at answering the questions that were asked. The first up is looking at the hypotheses. And of course, to construct our hypotheses, we want to first think about what's the claim that's being made. The claim here is that the forecast is inaccurate, that it's somehow different than what actually transpires. So that means that the forecast is going to be different than the actual, so that means they're not going to be equal to each other. And so mu sub d will not be equal to 0. Null hypothesis is by definition a statement of equality. And so we can just write that simply as mu d equals 0. Typically, we take the alternative hypothesis as the claim itself, and that's what we want to do in this case. There's no semblance of equality here. It not equal to means you're not equal to, okay? It's only when you're looking at the or equal to that there's a semblance of equality there. So there, we can just go ahead and just take this alternative hypothesis and, take it directly from the claim itself. So there's going to be a match here between our inequality sign and our hypotheses, and we're going to say that this is a two-tailed test because that not equal sign in our alternative hypothesis is the clue that we have a two-tailed test. Our test statistic is going to come out of StatCrunch because, I mean, you could go old school if you want, but it's way easier to get it out of StatCrunch. So, if you want to follow along with this in StatCrunch, go into the group there that we have there in StatCrunch and open up the weather forecast data file. And you can follow along with this problem. So pausing the video every so often, see if you can get the same things there in StatCrunch, and you can follow along for practice. So once you got your data there in StatCrunch, go ahead and go to Stat, T-Stats Paired. And in the option window that appears, you want to make sure that you put your samples in up at top, so tell StatCrunch where to look for that sample data. And then in the hypothesis test area, you want to leave that 0 pretty much by itself. And then I think the not equal to is the default selection there on your alternative hypothesis. So you can probably just leave that. Anyway, make sure that matches up, and then, away you go, press compute. Again, make sure you get them in their columns there in the right order. And once you hit compute, you get your test statistic. You can read it right off the results window. It's that next to last value there in your results window. P-value, just like we've seen before, P-value is going to be right next door to the test statistic, that last value there in your results window. Are you going to reject or fail to reject the null hypothesis? Well, depends on whether you're inside or outside the critical region. If you're outside the critical region, you're outside the region of rejection, therefore you fail to reject the null hypothesis. If you're inside, you reject the null hypothesis. So here's what we look like here in our distribution calculator there in StatCrunch. We're using the between option because we've got two tails for our hypothesis test. Of course, this calculator with the between option measures the area in between the tails. And so the alpha level is the area of the tails. So the area between the tails, we have to take the complement to get that area. And then out comes the critical values that we need to evaluate here and here. Those are the boundaries for our tailed region. That's our region of rejection or our critical region. So we go back and look at our results window. The p-value, if we use the p-value, 80% definitely much greater than 1%. And so, therefore, we're outside the region of rejection. We failed to reject the null hypothesis. Alternatively, we can use that test statistic. If we want to use the test statistic, the 0.258, that puts us right about here. So we're inside the region between the tails. The region of rejection is in the tails. Since we're outside the tails, we're outside the region of rejection, we reach the same conclusion, fail to reject the null hypothesis. What do we conclude from the hypothesis test? Well, we failed to reject the null hypothesis, therefore there is not sufficient evidence. We have a two-tailed test, therefore we warrant rejection of the claim. So the answer option with those two elements is going to be answer option A. Again, make sure you're really clear on the pattern and where the different pieces of this conclusion come from. We failed to reject the null hypothesis, so therefore there's not sufficient evidence. We have a two-tailed test, therefore we warrant rejection of the claim, and the rest of the statement is just a rehash of the claim itself. The appropriate confidence interval, well, there's a match between our claim and our alternative hypothesis. Therefore, we're going to want to use 1 minus 2 alpha to calculate our confidence level. So going back to our options window, there in StatCrunch, we just flip this radio button down to confidence interval, and then notice we've got to have 98% for our confidence level. That's because there's a match with our claim and our alternative hypothesis, and so therefore we want 1 minus 2 alpha for our confidence level. We press compute, and out comes our results window. We can take our lower and upper limits for our confidence interval directly from the end of the table. What do you conclude from these results? Well, look at our confidence interval. Is 0 inside or outside? Here we see 0 is inside the confidence interval. Therefore, it could potentially be the value that we're looking for. And if the difference between the two groups is 0, that means they're essentially the same. And so we have to conclude then there is no difference on average between the predicted and actual high temperatures. In other words, the 4 weather forecasts seem to be pretty accurate. Okay, so I guess Bill Murray's character needs to get more with some of his colleagues there in the forecasting industry and hone up on his skills a little bit, because that freak blizzard that came in and basically stuck him in Punxsutawney for most of the movie. He could have maybe foreseen that, and of course, if he avoided the whole thing, we wouldn't have the great movie that is Groundhog Day. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.